We're going to go through a couple things. Want to review regression stuff, right? This is the stuff we were doing. This is the technology that we're going to leverage technology to come up with a best fit line that we can all agree on that's going to model some data. Okay, so what we looked at on Wednesday, it's been a while. On Wednesday, we looked at this example, right, where we were given an object speed at various times. Okay, and we put this into Desmos as a table, right? We'll do this again today, so you'll get a little practice with this. Here's, we put the input values, we just left it as X, and the output we left as Y. The input here is time, the output is speed, right? Put that stuff in, we're able to see a graph of the scatter plot, which we did. We looked at, there's all the red points. Remember, if we click that little button there that's zoom fit, it sized it to where we could see everything nicely. We're able to see all the data. But what we wanted to do was more than that. We wanted to come up with a regressional fit. We want to fit the data to a line. It's called a linear fit using linear regression. So to do that, we took this stuff that we had come up with from our table, and we wrote this. We said Y1, not Y, Y1, because we want all the data in that column is going to be fit by this line, M times X1 plus B, right? So we want to figure out what are the values of M and B that are going to make this input data produce this output data with a line, okay? And we got an answer. We got that the slope was 3.29143 and the y-intercept was negative 1.5833. And that produced the best fit line, the line that most closely approximated that data, okay? And it even told us how good the fit was. Can anybody tell me what the percentage fit was on this? 93.74, right? That's where we look at R squared. R squared is telling us the strength of the fit, okay? It tells us, think of it, I mean, this isn't an exact interpretation, but a pretty good way to think about it. It's like saying, what percentage fit is that? If it's 100%, all the points would have been exactly on the line, which they're not, but they're pretty close. So it was pretty good. It was a 93.74% fit. Okay, 98% would have been better, but 85% would have been worse, right? So it gives you an idea, just relatively speaking, how good is this model? Pretty good. Okay. We did one more thing. We also said, what if we want to use this model to make predictions? Okay, we could then come down and we could use the values of M and B that we created with regression, and we could build a function using those values, right? So we could say f of x, like our output value, y, is equal to mx plus b, okay? And the m and the b have already been defined by the math gods with that regressional fit that we just did, right? That statistical analysis that we did using regression. And notice then that we got a blue line that perfectly overlaid the green line. They're the same thing, but this is more useful. The blue line is more useful because it's written as a function. So now I could answer the original question, which was predict the velocity when the time is 8 seconds. Okay, well, when t equals 8, we could then plug that into our function. We could just calculate f of 8, and it gives us a very precise output. 24.748, blah, 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 meters per second. Okay, so it's making, based on our data and our model, it's making a prediction for what the velocity would be at time t equals 8. Okay, and if we graph the point, we can see, of course, that point lies on the line because it's a product of that line, that linear function. So give me 1 to 5 on all that stuff. Does that all make sense, what we talked about on Wednesday? Okay. So this is what we did on Wednesday. This is called interpolation, answering this question. And it's interpolation because inter means inside. Like if you talk about, we use inter all the time. Like if you use an interscholastic, what do I like? Interscholastic sports. What does that mean? Say it again. Well, inter means inside. So what does interscholastic mean? Do you think? Okay, so inside of the school system, right? Interscholastic sports would be sports between schools. If you talk about an interconference game, you're talking about a game between two teams that are inside the same conference, right? Does that make sense? Okay. So inter means inside. This is interpolation because t equals 8 was a number that was inside of our data set. Our data set spanned the values from t equals 1 to t equals 20, and our prediction t equals 8 was inside of that data set. It was between the smallest and the biggest input values. Okay. What if we wanted to make a prediction when t equals 60? That's outside of our data set. What do you think we would call that? It is. So interpolation is a prediction. Oops. Using an input inside our data set. Extrapolation extra means outside. Okay. So that would be outside of our data set. Like what's an extraterrestrial? Creature from outside of Earth, right? Terrestrial means of Earth, so it's outside of Earth. Yeah. Right. Okay, so terrestrial just means of Earth. So outside of Earth is extraterrestrial. Okay. Okay. So actually, you know what we need to do also? We need to learn how to do this on our calculator. So let's do this once on our calculators. Totally forgot that last period. Let's try this. Bust out your TI-84s, and I'm going to show you how to do this. Then you can just watch. Just watch this process. Okay, so here's your calculator, right? I'm making the screen big. Okay, so here's all we have to do. We want to go when I want to input data on the calculator, I want to go to the stat screen. So I push stat, statistics. Okay. And I want to edit. I want to actually edit some data. I want to create some data or edit some data. So I'm going to hit enter. Okay, what's it do? Well, it gives me a bunch of lists. L1 means list 1, L2 means list 2, L3 means list 3. What's L4 mean? No, it actually means list 9. No, it means list 4. Okay, so we're going to create our L1 is always going to be reserved for our input variable. L2 is reserved for our output variable, right? And what this allows us to do is we could take the same input and maybe we want to create two different outputs from that same input or something. That's why we have multiple lists there. But very seldom will you use more than just L1 and L2. Okay, so input, we're going to just go 1, enter, hit enter to go down. 1, enter, 5, enter, 6, enter, 11, enter, 14, enter, 15, enter. And on the last one, don't hit enter. Hit the up arrow because you don't want to create another space. Now we're going to hit the right arrow and scoot over to the next column. So there are my X values for my table. Now I'm just going to input the corresponding Y values. So 3, 15.2, 18.7, 39.4, 34.5, 43.8, and 71.3. Okay, and then hit the up arrow so you don't create an extra space. Then you have to delete it, but yeah. So if I did, so what would happen? Like if I hit enter, it just creates another space, and I just have to hit delete. So I delete that spot. I think delete. Maybe I hit clear. Maybe it doesn't matter. I guess it doesn't even matter. Okay, I guess it doesn't even matter. Hey, the chit chat's got to stop, please. Thank you. So we've got, these are just like ordered pairs. X is 1, Y is 3, X is 5, Y is 15.2, etc., right? Or in this case, T and V. Okay, whatever you want to think of it. So now I've got my data. I need to create the model. Just like in the last example, right, we did this stuff. We need to do this stuff using our calculator, come up with the regression model. So here's how we do that. Now we have to exit out. So we're going to hit quit. We're going to go back to the stat screen, and we're going to scoot over to the calculate menu. So we go stat, calc, right? So that means I'm hitting the right arrow to scoot over to the calculate menu. And which option do you think we want? The linear regression, right? And we want the one where it says AX plus B. That's the more normal version for us. So it fits slope intercept form. So I want to choose this guy. So I'm just going to type 4. Okay, now look what it does. It wants to know, what is your X list? So what is the list that's feeding the math gods the input variables? Well, that was L1, wasn't it? Okay. Well, to get to the L's, notice they're behind the 1, 2, and 3. I could hit second and L1, second, L2. See what I'm saying? But you don't need to. This should be the default. Yours should already say this. Okay, this is the default. So like if this one, like if I wanted to make that L3, watch what I do. Here's watch me, Frederick. Watch up here. I hit second, and then I go down to 3, and it would make that an L3. Because see the blue number that's behind? For me, it's blue. Probably a different color for you. Okay. But I don't want to do that. I want to go back and change it back to L1. So I'm going to go second, 1, makes it L1. Oh, is it an 83? I'm not sure it's going to work. I'm not sure it's going to work. Okay, so the X list and Y list should be L1 and L2. You don't need to change that. That's always going to be that way. Frequency list, not even sure what that means. Store regression equation, that's really important, but I'm not going to do anything with it yet. I'll show you in a second. So then you could just go down to the highlight calculate and hit enter, and voila, look what it does. It tells me, okay, if it said air dim mismatch, here's your problem. That means that your data table, you had a different number of data points in L1 and L2. Okay, so you just go back, you just go stat, edit, and there it is, right? You would have had a different number. Yours wouldn't look like that. It won't clear out your whole. Stat, edit. Mine is exactly the same as his. Okay, it's definitely not. There's something else going on. Then here, can bring it up and I'll show you. I'll find your mistake. A lot of us have the same sort of calculator, but it doesn't work for me. You despise my rocks? My sister. Oh. Okay, stat calc 4. Oh, your frequency list. Oh, that must have been my brother then. Just delete on that, right? Yeah, just clear that. And now it'll work. There it is. Okay. Gotcha. Okay, so can I get your attention up here again? Yeah, I really would appreciate not to have to wait for everybody to quit their little. Okay, was that going to work? All right. So then, if we come down here, look what we find. We find that what was our prediction when we did stat calc? I left that, so I got to go back to stat calc 4, right? And then I'll just scoot down to calculate. I can scoot up to calculate. No, I can't. You have to go down to calculate. Hit enter. So our slope was 3.2914, blah, blah, blah. Our y-intercept was negative 1.5832, blah, blah, blah. So that should be what we got over here. If the world is sane, notice that is what we got here, right? And why is that? Well, because they're doing the same thing. Regressional analysis is just a statistical process that you take the data, it's the same every time. It's just the calculator and the computer do it very quickly. Okay, but what's missing from this page that might be useful that Desmos gave us that the TI did not? Oh, okay, yeah, it didn't give us the correlation coefficient R, and it did yours do it? Okay, some people's might have done it. Does that mean they have a fancier calculator? No, you can fix yours to be that way too. Here's how you do it. So let's quit. You quit, and then we're going to go into mode, and you're going to go down to stat wizards. Okay, so go all the way down. You want them on. So you're going to hit enter. Oh, sorry, stat diagnostics, not stat wizards. Yeah, no, you want stat diagnostics. You want to turn that to on. No, that setting will stick. So now you won't have to do this anymore. Okay? But if it ever goes away in the future, now you know what to do. Okay, now we can quit. We can go back to stat calc 4. And what do you know? We got that stuff. And look, it tells us that R squared, there's our, look, just what we got before, right? 93.74% accurate fit. How about that? Okay. But what it didn't do now, what's it missing now? So far, we've been able to do everything up through the green, up through row 2, but we haven't been able to do row 3 stuff yet, right? We don't have a model here to use to make a prediction, right? Okay, so how do I do that? So here's how I can do it. I'll go back to stat calc 4, and I'm going to go down to the store regression equation. So go down to this spot right there. Now what I want to do is I want to store this as y1. Think what y1 is. If we go back to the you don't have to do this, but if I go back to the y equals button, this was some stuff that we did a while ago, right? This is where we graphed some line, and then we graphed a horizontal line, and we looked for an intersection, right? If I go back to, I'm going to delete y2, but if I hit zoom fit, it's graphing that line that I have graphed in y1. Everybody agree? Okay. So my goal is I would like the math gods to put the regression equation right into my Y editor at Y1 so I can use it like a normal graph. Here's how I do that. I go stat, calc, 4, and I'm going to scoot down to store regression equation. I need to get a Y1 there. There are several ways to do this. If you forget, you can always go to the variables button. The variables button allows you to do all kinds of variables. Well, I'm going to go over to the Y variables menu and choose function Y1, and it inputs a Y1. Okay, well, how else could I do it? There's a quicker way. Here's a shortcut. A shortcut is you can just go to the alpha shortcut. You can go alpha one of these. If I go alpha F1, no, there it is. It's Y variables. So it's alpha F4. I'm going to hit the F4 button, and it gives me a shortcut to all of the Y variables. I'm just going to hit enter or 1, and it'll input a Y1 there. Now when I go down and hit calculate, everything looks the same here, but if I go to Y equals, look what it did. It put that big long regression equation with all that tremendous, look at all those decimal places it gives you for M and B. So it graphs that line for me. Everybody see that? Okay, so now I want to go to the graph and see this stuff. Okay, if I go to the graph, but the problem is it doesn't fit very well because the last thing I graphed had a different screen size. So what did I do before when I wanted to graph something new? Remember, I went to the zoom screen and I hit zoom standard. This time though, I'm going to hit zoom stat because zoom stat is going to do what zoom fit did for Desmos. It's going to fit the screen size to the data that I created in my table. Okay, so I'm going to hit zoom 9, and what's it doing? How come it didn't? Why didn't it do that? Zoom 9. What did it do? Turn that off. Let's go zoom 9. Well, that's kind of inconvenient. It's not supposed to do that. I don't know why it's doing that. It's broken. That's not what it does. It's supposed to graph this data. I know what it is. Okay, I know what it is. I got it. So you have to go turn on plot 1. That's it. If I turn on plot 1 and now I go zoom 9, there's my data. How about that? Okay. Okay, bring it up. Let me take a look. Okay, and then so listen, please. So while you're here, now we want to get that line back in there, right? So I'm going to go up to Y equals, and I'm going to go back. You highlight the equal sign to turn the line on, right? I unhighlighted it to turn it off. Now if I hit graph, look at that. Okay. Yeah, poor Lily. Let's see here. Oh, look, see. Okay, that's because you have something goofy in there.
Do I?
Yeah.
I don't know what's going on.
Okay, so we turn that off. We go up and turn plot 1 on, and now I hit zoom 9, dimension mismatch. Okay, let's go back to your stat edit. Okay.
I have an extra row in that.
That's why.
I don't know how to delete that.
That's just hit delete.
Oh, well, it didn't work before.
Oh, clear. No.
There's stuff going on. I don't know what's going on.
I thought you just hit delete. Enter. Clear. Oh, there we go. Oh man, I don't understand why that's not. I don't know. Here's one thing you can do. You can go up to the top. and you can
like
you can
backwards on
hit
my
you can hit clear the whole list and just input it again. Just do that. Yeah. I don't know why that wasn't working though. That should have worked. Okay, so here we go. Listen, please. Okay, I'm waiting. So we got our model here, right? Now I want to use the model to make a prediction, right? We want to know, what does the model predict for an input value of 8? Okay, so I can go then, we've done this stuff before. I can just go trace and I can input a value of 8. Oops, not like that. I guess I can't. Hang on. I got to go trace. Oh, and I don't want the plot. See, I'm on the plot right now. Everybody see that? If I hit the right arrow, I'm just going to jump from point to point. I don't want to be on the plot. I want to go to the line. So what do I do to jump from the plot to the line? Got to hit the down arrow. Down arrow. Because look, if I go to y equals, the plot's up there. I'm just going to scoot down to the line. Okay, so now trace, scoot down to the line. And now I can type in an x value. I can type in 8, hit enter, and there's my output. What do you know? Okay, everybody see that? Good. Okay, yeah, you can. That's everything we did on Desmos. That's how you can do it on your calculator. Okay. All right. So for today, let's look at one more quick example. What about this? This time, that's what we just did. Let's look at this. How about? So this shows the average price of a movie ticket, P of T, based on the year T. Find the linear regression model and use it to predict the year in which ticket prices will first reach $100. This is saying in 2012, average ticket price was $7.79, etc. So I need to enter all this data clearly, don't I? Okay. So what do you think, Desmos? You can do either one. I'm going to do Desmos. You can use your calculator or Desmos. I don't care. No. What do you mean? Hold it. Maybe I heard that wrong. Say that again. Oh, okay. Yeah. Okay. That does. So it doesn't matter, but there is a practical question here. So we're going to do ours, and I'm going to do mine in Desmos. But for my input values, right now, it looks like my inputs are going to be 2012, 2013, 2014, right? The outputs are going to be these small dollar amounts. What's inconvenient about that if I want to use the graph? Yeah, look at that. The x-axis, or whatever you want to call it, the t-axis or the input axis, our data is, we're not going to find our data until we go scroll clear over to like 2012. That's inconvenient, right? So what could we do instead? Okay, we could just do like 12. We could say, okay, the dates are going to be years since 2000, right? We can do 12, or we could even do 0, 1, 2, 3, 4, 5, 6, and we'll just define T as the number of years since 2012, right? It doesn't matter. I mean, we can do any one of those things. We just have to be consistent once we've done it. We have to understand what we're doing. Let's do that last one. Not that I mean, any of those would work, but let's go ahead and, what did that do? I don't know what that just did. Okay, so there we go. I'm going to make this a little smaller. And we're going to define on ours, we're going to say, ooh, that's pretty big. We're going to say T equals years since 2012. And if we do that, then what's my data going to look like? So remind me real quick. This is good review. You guys walk me through the steps because I can't remember, right? What do I have to do to get a data table? No, on Desmos. Plus, there you go. Table. Okay, so first column, we're going to say years since 2012. So 0, 1. Whoops. Now look, it sees the trend. It's pretty smart. So I'm just going to go up to what, year 6 and stop. Year since 2012, right? So then in Y1, I'm going to put all the other data, 7.79, 8.25, 8.47, 8.4, whoops, 43, 8.57, 9.01, 8.96. Okay, good enough? Okay, now I can call that, last time we called this X and Y. So this time I'm just going to change it around and I'm going to make this T and P, capital P, to match those. Okay, so it doesn't make any difference. But there it is. There's our data. It's not very convenient. How could I make it look better? How about zoom fit? Oh, there it is. What do you know? There's my data. Okay. All right, so now I need to get regressional analysis. How do I do regression? Okay, but instead of Y1, it's going to be P1, but not equals the squiggly, the tilde. So it's going to be right to the left of the 1. I've got the tilde. M T1. Okay, good. So M times T1 plus B. There it is, right? So there's my regression line. Okay. So now I want to be able to make this, though. Listen, please. I want to be able to make this a function. So now I'm going to write this as a function. Instead of using the sub ones, which means data, I'm going to use regular variables. P of T equals MT plus B. And now I get the same line. Notice the purple line sits right on top of the black line, but now I can input values, right? So for example, the first, or how about the second question? The second question wants to know what's the estimated ticket price in 2083? Okay, well, 2083 would be 71 years after 2012, right? So I'm just going to input 71, P of 71, and it's way off the screen. I'm going to have to zoom way out a whole bunch. Oh, what the heck? Oh no, I didn't make the data point yet. Okay, let's make a data point out of that too, so we can see it on the line. I'm just going to write an ordered pair. Input is 71. Output is, I don't have to write that whole number down. I'll just write P of 71 and let Desmos calculate it for me. And now if I zoom out a little bit, I should be able to see that point. There it is. Okay. So you can see the danger of extrapolation compared to interpolation, right? This is kind of a risky prediction because it's so far away from our data set that any small change in our data would have changed that line just a little bit. But even a small change in the slope that far away is going to change my output substantially. Everybody see that? So extrapolation is a little bit riskier than not a lot. Something like this is a lot riskier than interpolation. Question? Yeah, whenever I went to go trace, and then I inputted the thing. You're probably on the plot, I bet. No, I'm not. Okay. What was it, 73? So you just go, yeah. Oh, I know why. Okay, because you have to. So on the calculators, if you want to put, it would have been a 71. If you want to input a value like 71, you have to first, this is kind of dorky, but on the TI-84s, you have to size the screen so you could see that data point on the screen. So you have to go into window and just make it a lot bigger. Well, don't do that. Just go in window, and then just go down to like Y max. Instead of being 9, just make it like 100 or something. And now if I just go graph, okay. Yeah. And then I would trace. Oh, sorry, I did Y's. I didn't mean to do Y's. Darn it. Darn it, I messed that up. Let's go zoom 9. It's got to be the X values. Okay, so we're going to go window, not the Y values, the inputs. So make that like 100. and hit graph. And now you should be able to get it. Yeah, now it'll work. Yep. And then you could hit zoom fit so you can see the line. Okay. Okay, so everybody sees this, okay? So, but that's not the question that was being asked. We're going to run out of time, so I'm going to be really fast here. So the question that was being asked was estimate when the ticket price is going to reach $100. Okay, so if I look at this picture we just built, oh, I don't want to do that. Cancel. That's my. If I Where is it? Oh, right here. I am struggling. I got too many things going on my screens. So I want to figure out when this thing is going to hit a Y value of 100. Well, it looks like it's about there, doesn't it? If I want to know for sure, all I have to do is go down here and graph the line Y equals 100 and look for the intersection. There it is. So it's going to be 502.431 years after 2012. So that's going to be in about March of 2514 of the year 2514. March of 2514 is when this predicts movie prices will be $100 a pop. Yes. It would. Yep. It'd just be kind of less convenient on the graph, but it would. You're right. Yep. That's exactly right.